everybody and welcome back to my channel. Today I have a Rockford Fosgate amplifier. This time I got a mono amplifier, especially for subwoofer operation. The model number is T500-1bd. The continuous power ratings are 250 watts by 1 into 4, 400 watts by 1 into 2 and 500 watts by 1 into a 1 ohm load at 14.4 volts. The variable crossover frequency ranges from 35 to 250 Hz with a slope of 24 dB per octave. And the input of the amplifier is variable from 0.15 volts to 5 volts via the RCA inputs. The amp also features a bass boost at 45 Hz with a boost of 18 dB. An infrasonic filter is also available at 28 Hz with a slope of 12 dB. The T500-1bd was sent in by a nice subscriber. Thank you very much for sending in this amplifier for a dyno test. And now let's see what the amplifier can do.
And I'm starting with a continuous power test with 50 Hz and a 4 ohm load. In this case, I got a peak voltage of 44.4 volts. The amplifier delivers 252.8 watts into a 4 ohm load of continuous power with a 50 Hz signal. Let's have a look at the amplifier's efficiency with 50 Hz continuous power. The amplifier pulls 20 amps. The amplifier has an efficiency of 92.2%. Now I'm doing a power test for bandwidth limited amplifiers like subwoofer amplifiers, and this is similar to the CEA 2006 standard. That means I drive 10 cycles of 50 Hz into the amplifier, check the lowest and the highest cycle, and then we calculate the output power. Take a single shot. Looks okay. We have 43.6 volts at the lowest cycle, 45.2 volts. And now I'm doing a dynamic power test with 40 Hz and 4 cycles, that means 100 milliseconds. I capture this one, but look here, on the negative waveform we get dirty signal. So I go back until it looks good. The highest peak voltage I got is 41.6 volts with a 40 Hz burst of 4 cycles, that means 100 milliseconds. The amplifier delivers 221 watts. Now a 2 ohm load is connected to the amplifier and I start with a continuous power test with 50 Hz. I got a peak voltage of 41.6 volts. The amplifier delivers 455.5 watts into a 2 ohm load of continuous power with 50 Hz. And at 2 ohms we have a look at the amplifier's efficiency. It pulls 36.7 amps. The amplifier still has an efficiency of 90%. Now I'm doing the 50 Hz burst test, which means 10 cycles. And I observe the signal. It looks a little bit dirty at the negative waveform. Some distortion here. Let's have a look at the first one. Also the first is very dirty. You see this here. But it gets better at the last cycles. I will reduce. Okay, maybe that's the best I can get out of the amplifier. And then I got a peak voltage of Also 41.6 volts, so there's no dynamic headroom. Now the dynamic burst test with 40 Hz and 4 cycles. Single shot, and I see that there is still distortion in the waveform. I'm not going to measure the voltage with this kind of dirty waveform, but I can observe the peak voltage. It's 42 volts. Maybe I get it cleaner. Doesn't look too good. And now the voltage drops to 41.2 volts. Still distortion on the negative waveform. Not very good. So in this case, I take the voltage of this guy here. That's 40 volts at the highest cycle. The amplifier puts out 410 watts with a burst of 40 Hz at the highest cycle. This guy here is also a little bit lower and distorted, so this will not count, but this is okay. Let's say 410 watts. And now I have a 1 ohm load connected to the amplifier, and the first test is 50 Hz continuous power. Gets dirty. I reduce my input signal. Still gets dirty. This is what I accept. And peak voltage is 34.4 volts. With a 1 ohm load connected, the amplifier delivers 591.8 watts. And let's have a look at the amplifier's efficiency with 1 ohm. The amp pulls 53.4 amps. Let's calculate with 53.6 amps. I calculated an efficiency of 80.5%. I'm not getting any more dynamic power, but this time I test with 10 cycles and 100 Hz. And we have all cycles at the same voltage level. Let's have a look. Not very clean here. I go to the last cycle. Also not very clean. Slightly distorted, so I take this voltage here of the cleanest cycle. That's 36 volts with 100 Hz and 10 cycles. That means 100 milliseconds. The amplifier delivers 647.9 watts. I also tested with 200 Hz cycles, but I don't get more than 36 volts of peak power out of the amplifier. Now a half ohm is connected to the amplifier's outputs, and I try to get some dynamic power out of the amplifier with 50 Hz and 10 cycles. So let's check this guy out until it gets clean. But the amplifier shuts off now and is back. Amplifier is still operating, voltage is growing, voltage gets dirty, I think. Yes, I reduce my signal. Still distorted output with an half ohm. That looks not too bad. But let's have a look what kind of peak voltage we have here. I stop signal input. Don't want to kill this amplifier with a half ohm. I get 24 volts. Now I'm testing with 200 Hz and 10 cycles. If we can squeeze out a little more output power. So I got a higher voltage. That's 26.4, but let's have a look at all the cycles here. We get distortion. But they look okay, not too good. Let's calculate with 26 volts. With a burst of 10 cycles with 200 Hz, the amplifier delivers 676 watts into a half ohm.
Thank you very much for watching. If you like this video and you find it useful, leave a thumb up or subscribe to my channel. If you already did, don't forget to hit the bell button to get infos about the next videos I'm planning to put out in the future. Thanks again, see you again, bye bye.